In this video, we will build a frequency table in Excel to count how often each value occurs in a data set. A grocery store asked 51 customers, "How many times do you visit this store in a month?" Their responses are shown here. What if the store manager wants to know how often customers reported visiting 4 times per month? To make it easier to work with our data, let's first sort it. There are several ways to sort data. Let's add a filter to the column to do it that way. Select the cell at the top of the column with the label in it and click Sort and Filter, Filter. Notice the drop-down arrow has been added. That means that this is now a filtered column. Click on the drop-down arrow and choose Sort Smallest to Largest. Our data is now sorted. As you can see, customers visited once, twice, up to 15 times per month, according to the 51 customers surveyed. We could manually count our values with only 51 data points, but what if we had hundreds or even thousands of rows in our spreadsheet? What we want is a frequency table, which shows how often each observation or each value occurs in our data. Excel does need to be told what values to count, but once we tell it that, it will count them for us. So, for example, it will need to be told, count the number of times you find 1 in your values. Count the number of times you find 2 in your values. In order to set up the list of numbers for Excel to count, let's copy and paste our data from this column into a new column. So I'm going to click Control-C, and on a Mac it would be Command-C. And then I'm going to put it into a new column, Control-V, and then on the Data tab, I'll click Remove Duplicates. It's going to ask the data in column H is what you want. I don't have a header, so I don't need to choose header. And when I click OK, it tells me that it found 37 duplicate values and removed those duplicates, and I have now 14 unique values. All of these are the values that occur in my data. Each one occurs once or more often. Notice that 13 is not in this list because we did not have any customers say that they visited 13 times in 1 month. Each unique value is treated as the upper value in a range by Excel. Excel is going to count how many values are in our data set up to and including the number 1. Then it's going to count how many values it finds between the numbers 1 and 2, including 2. Then it will count how many values are found between 2 and 3, including 3. This is a bin. It's also known as a class interval. So we're going to call this column bins. The next column is where Excel is going to record the frequency with which each of these bin values occurs. I'll widen the column a bit. Now we're going to select all of the blank cells in the frequency column next to a bin value, and then with those cells selected, type equal frequency, and you can see that a formula comes up and open parenthesis. It tells us that there are going to be 2 things in this formula, the data array and the bins array. The data array is the value that we want to count. We're going to select, not including the column header, all of the values from E2 to E52, comma, and then we're going to select the bins values, close parenthesis, but do not hit enter. This is what's known as an array in Excel. We're having the output entered, the results entered in more than one cell, and so you need to hit a special series of keystrokes in order to activate an array command. If you have Windows, the sequence of keystrokes is Control-Shift-Enter, and it will put the output into the blank cells. If you have a Mac in Excel 2016, you can use Control-Shift-Enter, and if that doesn't work, then it's Command-Shift-Return. That is CMD-Shift-Return. Now we can see that the cells have filled in, and as you notice in the formula bar, the frequency formula now has curly brackets around it. The curly brackets indicate that we have used an array command. The answer to our original question, how many customers visited the store 4 times in a month, is 9 out of 51 customers. In this video, we've demonstrated how to build a frequency table using the frequency array in Excel. In this video, we will build a horizontal bar chart in Excel. The data in this file represent the last 12 months of sales for 10 salespeople. These salespeople attended a training program a year ago, and their rank in that program is here in column C. We might believe that rank in the training program should correspond with sales volume, and it would be easier to see whether that corresponding effect exists by putting our information into a graph. A bar chart is a good graphical choice in this case because we have multiple variables, i.e. sales by 10 different salespeople. Bar charts can be horizontal or vertical. In this video, we'll build a horizontal bar chart, which Excel calls a clustered bar. Excel has made charting as easy as pushing a button. If I want to include the names and the sales in a bar chart, I select the data and then click the small icon which is at the bottom right of my data. This is a shortcut button for graphing. I click on Chart and then I choose Clustered Bar. You can see the preview shows me what my chart will look like. My chart is now inserted into my file. On my y-axis, I have the first column of data, which is the name of the salespeople. Notice that the top of my list is the bottom of the vertical bar chart. The x-axis is the sales data. Of course, we still need to add labels. And before I do that, let's get even fancier. Since we're interested in whether rank in the training program corresponds to higher sales, let's delete this graph, then sort our data by the ranking and insert another graph. Sorting our data is easy. Let's select all of our text, and then on the Sort and Filter, we'll choose Custom Sort, and my data has headers has been checked off, so we're going to sort by ranking in training program. Should we leave it at smallest to largest? Why would it make sense to change it to largest to smallest? If we believe sales will get larger as the ranking gets smaller, in other words, the top ranked trainee out of the program should have the highest sales, and our vertical bar chart will start with whatever is at the top of our list in the bottommost bar, then I would want to sort from largest to smallest, and that would put my 10th place salesperson at the bottom of the bar chart. Now we can insert the bar chart again. Of course, we can also go to the Insert tab and either choose Recommended Charts, or here we have the choice for several different kinds of bar charts. And now we can see that Arden, who is the first place ranking, is at the top of the chart, and Arbuckle, who placed 10th, is at the bottom. We don't see the relationship that we expected to see. We could substitute the rank in the training program in place of the person's name. Excel makes it quite easy to do that. Let's go ahead and click on Select Data. And then what I want to replace is this horizontal category axis label. I click Edit, and then I'm going to choose, notice that the marquee blinking is around the representative names. I want to instead choose Ranking in Training Program, and you can see the chart is changing on the screen. I click OK, and OK again, and now that's been done. Now let's add our axis labels. This plus sign is another shortcut menu. I can add my axis titles here. Of course, there are a lot of other things that you can also add. And to change them, I simply click inside this text box. And so I would call the x-axis annual sales in thousands, and the y-axis would be ranking. I've made my y-axis label as descriptive as possible. Now we can change the title of our graph. Annual sales in thousand by rank and training program. You want your chart to be as descriptive as possible so that the audience is able to understand at a glance what information is being presented in the chart. In this video, we've created a horizontal bar chart in Excel. In this video, we will build a vertical bar chart in Excel. The data in this file represent the last 12 months of sales for 10 salespeople. These salespeople attended a training program 12 months ago, and their rank in that program is shown in column C. We might believe that rank in the program should correspond with sales volume, and it would be easier to see that information in a graph. A bar chart is a good graphical choice in this case because we have multiple variables, i.e. sales, by 10 different salespeople. Bar charts can be horizontal or vertical. In this video, we'll build a vertical bar chart, which Excel calls a clustered column. Excel has made charting as easy as pushing a button. First, we'll sort the salespeople by rank, because we might believe that salespeople who placed higher in the training program will have higher sales for the year. We sort by selecting all the data, going to Sort and Filter, Custom Sort, and then choosing Ranking in Training Program. We would like to have the data represented on the chart by largest ranking to smallest ranking. That is, if we believe that sales will be reflective of rank in the training program, then we would like to see sales grow as the rank improves in the training program. Now that the data are sorted, we can select the data to graph. Click the small icon that shows a graphing shortcut option, and then choose Charts. Clustered column is the first choice provided to us. A graph is automatically inserted into the spreadsheet when you click on that choice. We're almost done. Good chart etiquette requires labels on the X and Y axes and a descriptive title so your audience can understand the message in your chart. However, what if the sales manager did not want to show the names of his salespeople on the chart? We can anonymize the graph by having rank represent the person. Changing the x-axis is easy. Click to select the graph, then click Select Data on the Chart Tools Design menu. Click Edit for the horizontal category axis label, and then we want to select Rank in Training Program. You can see that it's going down to the 10th row, which is C11 for my data. Clicking OK a couple of times changes my graph. Now I have the information represented in the graph. It's time to add my axis titles. I click the plus sign and axis titles, and then in order to actually change what is in the axis title, click on it, highlight the text, and type what you would like to see there. I've changed the X and Y axis in this graph. Now we'll change the chart title to make it as descriptive as possible. We would like to ensure that the audience looking at our graph can understand the message that we were trying to convey. One quick note about formatting. There are other places that we can do formatting of our charts. On the ribbon in the Design menu, we have Chart Styles and Quick Layout. Both offer multiple options for designing your chart. Quick Layout, for example, you can see by mousing over each choice how it would change your graph. Chart Styles has some fairly fancy ways that you can change your graph. In this video, we've created a vertical bar chart in Excel. In this video, we will build a pie chart in Excel. In this file, we have data from 240 department store buyers who viewed a new line of dresses and gave their opinions on the clothing line on a scale from undesirable to outstanding. A pie chart is a good graphical choice to represent these results. It is often appropriate when showing frequency for a qualitative variable, as in this case. Select the data, and when the shortcut option shows up in the bottom right of the column, click it. This gives us multiple graphing choices, and Excel will recommend what it believes to be the best graph for our data. Clicking on Charts, we can see that Pie Chart is one of the choices, and we get a preview of the pie chart as soon as we mouse over it. Click on Pie, and the graph is inserted into our Excel file. It's difficult to see a difference between the pie slices here, so we would like to add something so that people looking at the chart can see the proportional size of the pie slices one to another. The easiest way to do that is to click on the plus sign and mouse over data labels, click the arrow to the right, and then choose More Options. Another menu opens, offering us multiple ways that we can modify our pie chart. Click on the percentage and unclick Value, and you can see on the pie chart that outstanding represents 19% of the total for our chart. We're about done with the pie chart, although I would revise the title in order to make it more descriptive. Click the title in order to select the text, and then type whatever name you would like. Note that the percentages are similar across the categories. It's hard to grasp the message in this graph. In order to make our data stand out more, we could combine some categories and see what it looks like then. For example, let's combine outstanding, excellent, and very good into a single category. Let's close this menu to give a little bit more space on the screen. I've moved my pie chart out of the way and created a category called Outstanding, Excellent, Very Good. The 132 is the total number of buyers who selected one of those three categories. Let's create another category where we'll combine Good and Fair. Good and Fair have a combined total of 74 scores from the buyers. And the final category is Undesirable, and that one has 34. Now let's create a pie chart and see what the data tells us. So we will first want to add the titles, and now we'll select our data, click on the shortcut menu, Charts, Pie, and it inserts the graph for us. Again, we can add percentages to our data, and now we can see that 55% of the buyers chose outstanding, excellent, or very good. 14% chose undesirable. This is a way for us to separate out those who gave a very positive score from those who did not. Finally, note that there are multiple options in pie chart design. On the Chart Tools Design tab, in both Quick Layout and Chart Styles, preset menus make it easy and quick to add pie charts if that's the suitable graphical style to showcase your data. In this video, we've created a pie chart in Excel. In this video, we will build a line graph, also called a line chart, in Excel. The data set in this file contains 10 years of sales for a mail order retailer. Line charts lend themselves best to quantitative, time series data. Excel makes creation of a line chart as quick as pushing a button. Select both columns of data, including the labels. Note that Excel will treat the first column as the values for the x-axis and the second column as the values for the y-axis. When the shortcut button shows up at the bottom right of your selected data, click it, or of course you can go to the Insert menu on the ribbon. The first recommended chart type is a line chart, as you can see. Excel has some built-in intelligence to note that you're probably using time as your value on the x-axis, and it will automatically recommend a line chart in that case. Click the chart, and then click the plus sign for another shortcut menu, or on the Chart Tools ribbon, in Design, click Add Chart Element. Add axis titles for your primary, horizontal, and for your primary vertical. You can also modify the title so that it is clear as possible to your audience what is represented in your graph. Finally, note that there are multiple options to spice up your chart design. On the Chart Tools ribbon, in both the Quick Layout and Chart Style sub-menus, which are part of Design, preset menus make it easy and quick. In this video, we've created a line chart in Excel. In this video, we will use a versatile, easy-to-use feature in Excel called a pivot table to build a joint frequency distribution, also called a cross-tabulation or a contingency table. This data set has salary and positions for 25 players from the 2016 roster of the New York Yankees of Major League Baseball. Let's build a joint frequency distribution to show the frequency of salary range by types of position. There are a lot of values in the salary column. When there are many different values occurring in a data set, it is easier to group the data, that is, to define class intervals for our data. Excel will then count the frequency with which values occur in each class. Click inside the data set to build the pivot table. On the Insert tab, click Pivot Table. Notice that all of the data in the file has been automatically selected, as shown by the blinking marquee around the data. In the pivot table fields, drag Salary to the Columns box, then drag Position to the Rows box. Drag either Position or Salary to the Sum Values box. What you see inside the pivot table is not the counts we were expecting. Right-click in the data and choose Summarize Values by Count. There are too many data values to have a meaningful frequency count with the raw data for salary. Let's group our data into salary ranges. Right-click on one of the salaries in the Column Labels row, choose Group. Excel suggests a starting point, which is at the bottom of the data range. It suggests a class interval, in this case $1 million, and an ending point based on those intervals. However, if we accept the default, there will be too many classes. The rule of thumb in class intervals is 20 or fewer, and with only 25 rows of data in my file, I'd rather see the data grouped into far fewer. The person building the pivot table makes the decision on how many classes, so I'll choose 5. The easiest way to get 5 classes is to take the range from 500,000 to 25 million and divide by 5. That tells me the interval will be $4.9 million. I'll uncheck Starting, and I'll enter 500,000 here, and I'll enter 4,900,000 in Buy. Then I can click OK. Now my table is a much more manageable size. I'm going to close the pivot table field so we can see all of it. How do we read this table? The grand total column on the right-hand side is the total of our position types. The grand total row on the bottom is the total of our salary ranges. There are 2 catchers total. One catcher earns between 500,000 and up to but not including 5.4 million. The other catcher earns between 15.2 million and up to but not including 20,100,000. We can actually show relative frequency inside the table, not just counts. Right-click in the table. Under Show Values As, change to % of grand total. On the bottom grand total row, 52% is the percent of total players who earned between 500,000 and just under $5.4 million. On the grand total column, 8% is the relative frequency of players who are catchers. Inside the table, we see that 4% of all players are in left field positions, with a salary between 10.3 million and almost 15,200,000. You can calculate these same numbers for yourself. If we switch back to no calculation, we can take this 2 and divide by 25 to get the 8% who are catchers. We can take this 13 divided by 25 to get the 52% who are in the lowest salary category, and this 1 under left field divided by 25 will tell us that 4% of our players who are in left field are earning between 10.3 million and 15.2 million. In this video, we have demonstrated how to build a joint frequency distribution table, also called a contingency table, in Excel using the pivot table feature. In this video, we will use a versatile, easy-to-use feature in Excel called a pivot table to build a frequency table. With a pivot table, we can quickly build a frequency table, add relative frequency, and add charts. This data set has salary and starting positions for 25 players from the 2016 roster of the New York Yankees of Major League Baseball. Let's build a frequency table for the qualitative variable position. Excel will count how often each position occurs in our list. Click anywhere inside the data set, and then on the Insert tab in the ribbon, click Pivot Table. Notice that all of the data in the file has been automatically selected. Accept all of the default settings that are in this Create Pivot Table menu and click OK. A new sheet has been created with a pivot table set up. In the pivot table fields, drag Position to the Rows box. Also drag it to the Sum Values box. The data are automatically sorted alphabetically by title, and the count has been added as another column. Note that our grand total adds to 25, which we know is the number of players in our data set. It's always a good idea to ensure your data adds to the number you expected. Right-click in the Count column, and you'll see multiple menu items. Under Summarize Values by, Count is selected. Sometimes I have seen Excel default to Sum here. To show a frequency count, make sure Count is selected. In the Show Values As menu, note that we're not performing any calculations. We are simply doing a count. Now, let's add relative frequency to this table so we can easily see what percent of the roster is filled by each player type. Drag Position to the Sum Values box again. A new column is added to our table, Count of Position 2. We'll turn this into our relative frequency column. Click the drop-down by Count of Position 2 in the Sum Values box. Or right-click in the Count of Position 2 column and choose Value Field Settings. On the Show Values As tab, under Show Values As, click on Percentage of Grand Total and OK. Our counts have now been converted to relative frequencies. Let's change the column header. Click on the Count of Position 2 and in the formula bar, type relative frequency. We can see that relief pitcher is the most frequently occurring position. 28% of players are designated relief pitcher. It may be useful to sort our data by relative frequency so that we can see which positions occur most often in this Major League Baseball team. I've shifted my screen so that we can capture the next menu. Under Row Labels, click the drop-down and choose More Sort Options, and then choose Ascending A to Z by Relative Frequency. Choose OK. And our table has now been sorted from smallest to largest frequency. We can also easily add a pie chart. Click in the pivot table. On Insert, choose Pivot Chart. I'll go with the 2D pie, and now a pie chart has been inserted into my pivot table sheet. In this video, we have demonstrated how to build a frequency table with a qualitative variable using the pivot table feature in Excel. In this video, we will use a versatile, easy-to-use feature in Excel called a pivot table to build a grouped frequency distribution with a quantitative variable. This data set has salary and positions for 25 players from the 2016 roster of the New York Yankees of Major League Baseball. Let's build a frequency distribution based on the quantitative variable of salary. There are a lot of values in the salary column. When there are many different values occurring in a data set, it is easier to group the data, that is, define class intervals for our data. Excel will then count the frequency with which values occur in each class. Let's get started building the pivot table. Click inside the data set. On Insert, click Pivot Table. Notice that all the data in the file has been automatically selected. You can see the blinking marquee around the data. Accept all of the default options in the Create Pivot Table pop-up and then click OK. In the Pivot Table fields, drag Salary to the Rows box. Drag it also to the Sum Values box. The salary column in row labels has been sorted lowest to highest salary. For a frequency table, we want to see a count, not a sum. Right-click in the Sum of Salary column, choose Summarize Values By, and click Count. You can see that the grand total adds to 25, which we know is the number of players in our data set. It's always a good idea to ensure your data adds to the number you expected. There are too many data values to have a meaningful frequency count with this raw data. So let's group our data into salary ranges. Right-click in the Row Labels column and choose Group. Excel suggests a starting point, which is at the bottom of the data range, and suggests a class interval, in this case $1 million, and then identifies the ending point based on the intervals. Let's accept the default and see what happens. Our column is not as long as it was, however, there are still too many classes given the relatively small data set. I think I'd like to see 5 classes. How shall I determine the class interval? The easiest way is to take the range of my data, starting with the highest value, which is 25 million, and subtracting from it the lowest value. I'm going to round that down to a nice round number and make that 500,000. That will give me a range, and then I'll divide it by 5 so that I know how large my interval needs to be. A class interval of 4,900,000 will give me 5 classes. Now I'll go back into the group, uncheck starting at, and change that to 500,000, and change by to 4,900,000, and click OK. Now you can see that I have 5 classes. Each one is 4,900,000 wide. I'm going to delete this cell that has the calculation since we don't need it anymore. And let's add a relative frequency to my data. We'll drag salary to the Sum Values again, and now we have a Count of Salary To column. I want to change that to frequency. Right-click in the column and select the Value field settings. Then Show Values As and change it to % of grand total. We now have a relative frequency for the Count of Salary, and I want to change my column header to relative frequency, which I do in the formula bar above. Now we can add a histogram. Click in the pivot table. On Insert, choose Pivot Chart. If you try to insert a histogram, that option isn't available with pivot tables. No problem, we'll make our own. Click on Column, and then insert the clustered column. Note that both of our columns are represented in this graph, and we only want Count of Salary. We'll right-click on Relative Frequency and Remove Field. To make it a histogram, we need to remove the gap between bars. They should be touching in a histogram of a continuous distribution. Right-click in the chart and choose Format Chart Area. Under Chart Options, click on Series Total, and then click the chart icon and change gap width to 0. Change border to solid line. We can close this menu, and we now have a histogram. So we can get rid of the legend. We don't need the legend in the histogram. We can add labels to the histogram by pressing the plus sign and clicking on Axis Titles. In this video, we have demonstrated how to build a frequency distribution using the pivot table feature in Excel. We grouped a quantitative variable into class intervals, added a relative frequency column, and then built a histogram using the pivot chart feature. In this video, we will build a relative frequency distribution and a cumulative frequency distribution using a frequency table. This data set represents 51 customers of a grocery store who have responded to the question, how many times per month do you visit our store? You can see the raw data in column E under the times header, showing that, for example, we have 6 customers who reported visiting the store once per month. The information from column E has been transformed into a frequency table. The column bins represents the answers that survey respondents gave, the number of times they visited. The frequency column is how often each of those answers was given by the 51 respondents. Additional helpful information can be drawn from the frequency table. For example, if we wanted to know what percent of the total is represented by 4 visits per month, or we might like to know, did any responses occur less than 5% of the time? Relative frequency will answer these questions. It turns out to be easy to add this type of information to our table. For relative frequency, let me go ahead and add the column header. We're going to look at what percentage of the total responses is represented by this frequency of 6 or this frequency of 3. To do that, we need to sum this column of frequency. Excel provides us a way to do that automatically with this sigma. If you click it, it will insert the sum of the data that's above it. I'll hit enter and it puts in the answer. Relative frequency would then be 6 divided by 51. I'll enter that as a formula equals the cell of I2 divided by this total. Now I'd like to drag this down the column rather than having to enter the formula each time. But if I drag it down the column, my denominator and the numerator cells will iterate. I want that to happen in the numerator. I want it to point at first the frequency result for bin 1 and then for bin 2 and 3, but I don't want it to move away from this total in the denominator. So I want to lock this cell. If I click back in my formula, put the cursor right after the I16 cell reference, and then on a Windows machine, it's the F4 key. When you press F4, you note that it puts dollar signs around the I and the 16. If that doesn't work, you may need to push the Fn or function key and then press F4. On a Mac, it is the CMD or command key and the letter T. Once I've done that and I hit enter, the next thing is that I'd like to make it a percent rather than having it in decimal format. And now I can grab the square in the bottom right and drag it down my column. And if I've done this correctly, the frequency column will add up to 100%, and it does. The cumulative frequency column will tell me for any bin value, the total amount of data up to that point is X%. We'll start with the first cell, and then I can't yet drag it down the column because now I need to create my formula. I'm going to look at what is the value of relative frequency for this bin value, and then I'm going to add to that the total of the cumulative frequency column above it. Now I've created a cumulative frequency for 1 and 2, which is 18%. And now that I have a formula in the cell, I can drag it down the column. To check that you've done this correctly, the final value should be 100%. Let's answer some questions using the relative and cumulative frequency distributions. what, if any, responses occurred less than 5% of the time. We can see that 8, 9, 10, 11, 12, 14, and 15 are all less than 5% of customers reported that many visits per month. How many customers visit less than 4 times per month, or what cumulative percent is represented by visits less than 4 times per month? In that case, we're looking at those who visit once, twice, or 3 times per month, and the cumulative frequency for that is 27%. In this video, we have demonstrated how to create relative and cumulative frequency distributions in Excel. In this video, we will build a frequency distribution with a pivot table, and using the pivot chart function, we'll build a frequency polygon. Our frequency polygon will look like the one you see here. Similar to a histogram, it shows the shape of our distribution. The points in the graph are the intersection of each class midpoint and class frequency. We'll build this polygon as a line graph with markers. This is our data set. A company collected data on the daily number of oil changes at one of its shop locations for 20 days. We're going to convert this raw data into a frequency distribution using a pivot table. Click inside the data, insert pivot table, click OK, drag changes to the rows section and changes to the values section. Click on the data. Under field settings, change it to count and say OK. Now we have a frequency count. However, it's every value from our data set, and it's not very useful to show the shape of our distribution if we see that 51 occurred once and 62 occurred twice. We'd like to group them into bins in order to see the frequency across classes. Excel offers built-in functionality to create groups for us in a pivot table. Click inside your pivot table to activate the menu. Click on Group, Group Selection. The starting at will be the lowest value in the first bin. The ending at is the highest value. And 10 is the interval suggested by Excel, in other words, the class width. A rule of thumb in creating groups is to have them be multiples of 10 or 100, so this looks like a good interval for us to use. However, another rule of thumb is that the starting bin, the first lowest value, should be a multiple of your interval. So let's make this 50, and then Excel will automatically change the ending. And as you can see, I now have bins that go from 50 to 59, etc. They are 10 units wide, and I now have a frequency distribution based on those classes. A frequency polygon should be anchored at the start and the finish point by a 0 so that it looks like a mountain rather than a line in space. If you click the drop-down by row labels, you'll see that there are actually classes less than 50 and greater than 100, but they have values of 0. Click on Field Settings, Layout and Print, and Show Items with No Data. And then right-click in your table, click on Pivot Table Options, and for empty cells, Show 0. Now we have a starting and ending class in our frequency distribution, which we will use to anchor our frequency polygon. A frequency polygon uses the midpoint of classes as the value shown on the x-axis. The midpoint is simply the lowest bin value from bin 1 and bin 2 averaged together. In other words, I've taken the 50 from my 50 to 59 class and the 60 from my 60 to 69 class, averaged them, and found the midpoint for class 50 to 59 is 55. I did the same for the class above it. Now I can see easily my midpoints are 10 units apart, which is not coincidentally also the interval. And now I can substitute those midpoint values in for my row labels. And I'm now ready to insert my graph. Click inside the data to select it, insert, pivot chart, choose line chart, and the fourth one over has markers. It shows us what our graph will look like when we hover over it. Click OK, and we now have a frequency polygon very similar to the one that you saw at the beginning of the video. I'm going to move the graph over so that some of the pop-up menus are visible. We don't need the legend, we can delete that. We can change our title by clicking in the box and typing in whatever we'd like. We can add axis titles by clicking the plus sign and choosing axis titles. We have now created a frequency polygon using the pivot table feature and pivot charts in Excel. In this video, we will build a frequency polygon from a frequency distribution using a line graph in Excel. Our frequency polygon will look like this one. Similar to a histogram, the polygon shows the shape of our distribution. The points in the graph are the intersection of each class midpoint and class frequency. We'll build this polygon as a line graph with markers. This is our data set. A company has provided a frequency distribution for hourly wages of 270 employees. Note that the data in the bins are from the lower number up to but not including the upper number. In other words, this up to $6.50 would include $6.49, but not $6.50. To build a frequency polygon, we first find the midpoint of each class. Classes are also called bins. Midpoints are the average of the lowest bin value from two classes. In this case, we would take the average of 550 and 650 to find the midpoint of that first class. I'm going to insert a midpoint column in between hourly wage and frequency. I've already created the first midpoint value, 550 plus 650 over 2. I'll do the next value and then the pattern will be obvious. You can see the next midpoint is $7. Our class width is $1, and the difference between each midpoint is $1. I really don't need to do any more calculations. I can fill in this column 8, 9, and 10. The first and the last class need to have a frequency of 0 in order to anchor the polygon to the x-axis so that it looks like a mountain instead of a line floating in space. To do that, we'll cheat the system a bit. I'll insert a new row above and below, and it's easy to see that my midpoint here would be 5 and here would be 11. And then I'll put a frequency of 0, and we're now ready to do the line graph. I'll select these two columns, and when my quick analysis button pops up, click it, and on the charts, notice that it does recommend a line graph, however it doesn't have markers. Click on More. Under All Charts, I want the fourth choice. Notice it gives me two choices here, and if I hover over each, it shows me what it will look like with my data included. I want the frequency graph, which has only one of my lines in it. This one will include both the midpoint as its own line and frequency, but I only want the frequency. Clicking on this one and then OK inserts it into my Excel file. We're almost done. Good charting would require us to change the title to something more descriptive and add axis titles. I've changed the title. If I click on the graph and click the plus sign, I can add axis titles. Clicking inside those allows me to change the text. The more descriptive we make our axis titles and our graph title, the easier it is for a reader to interpret the data inside it. We have now created a frequency polygon from a frequency distribution by adding a midpoint column, adding new classes with frequency of 0 at the beginning and end of our frequency distribution, and then inserting a line graph with markers. In this video, we will build a histogram using the new histogram chart feature in Excel 2016. The data you see here represents the number of times 30 different ATMs were used on a single day. I've sorted the data so that we can see the distribution of raw data. In other words, one ATM was used 36 times and one was used 95 times. The others were in between those two values. A histogram is a great tool to see the shape of the distribution of our data. Excel now makes it easy to build one. Select your data with or without the label. I'm going to exclude the label. On the Insert tab, in Recommended Charts, click the All Charts tab, select Histogram from the list. Click on the graph. It will show you a preview of your graph. Click OK. A histogram has been inserted into our chart. I'm going to move the histogram to the top and then make it just a bit bigger. We have some cleanup to do on this histogram, and we need to make some decisions. As you can see, our data have been sorted into 4 bins. How did Excel choose the number of bins? Instead of the formula you may have seen before, 2 to the k greater than or equal to n, where k represents the number of classes that we are seeking to solve for, and n is the number of data points, which in this case would have suggested 5 classes, Excel uses something called Scott's normal reference rule, a binning algorithm that seeks to fit data to a normal distribution. In histograms, all bins should be of equal width. 2 things to be aware of with the way these bins are set up. The first bin is wider than all the other bins. Note how the intervals are 36 to 53, 53 to 70. The upper limit in the bin is included in a bin, so the 53 is included in the first bin. In the next bin, though it seems to start at 53, that bin does not include the value of 53. However, in the first bin, 36 is part of that value set. Therefore, the first bin is 1 unit wider than all the others. Also, recall that I said that Scott's normal reference rule assumes that data are normally distributed. If we look at a different number of bins, we may see a different picture. You can modify the number of bins or the bin sizes rather than accepting Excel's automatically chosen limits. Click on your x-axis and in the Format tab under Chart Tools, choose Format Selection. Here I can choose bin width or number of bins. If I click on number of bins, you can see that some change has already occurred in my data. I'm going to change this to 5 bins. Now the data looks quite a bit different in our histogram than it did when we first began. Now I'm going to change my bin width to 10. Notice that Excel will automatically adjust the number of bins based on my bin width. Again, the picture changes. It's a good idea to play around with the bin width and number of bins to see how the picture of your data changes. When you're happy with the histogram, don't forget to add axis titles by clicking the plus sign. You can change the titles by clicking inside the text boxes and typing the title that you'd like. In this video, we have built a histogram using the histogram chart feature in Excel. In this video, we will build a cumulative frequency polygon using Excel's pivot table and pivot charts feature. A cumulative frequency polygon is also called an ogive, and I will use both terms. This is what our ogive will look like when we are done. The markers in the line graph are the intersection of the class and the cumulative frequency of that class. Note that we have both a primary and a secondary y-axis. Most polygons are roughly S-shaped, and they always are up and to the right because we're using cumulative frequency. The data here represents the number of times 30 different ATM machines were used on a single day. I have already sorted the data, and it shows that the lowest usage of an ATM was 36 times, the highest usage was 95 times. But I'd like to see the cumulative frequency of my data. We'll begin by building a frequency distribution with a pivot table. Clicking in the data, Insert, Pivot Table, accept the defaults. I'll drag used to rows, used to values. Notice that right now my column is the sum of used, and I'd like that to be a count. The next thing that I'll do is change my rows to be classes instead of the individual values. Clicking here, I'll choose Group Selection. When we create an ogive, the values on the axis will be the top of each class boundary, and I'd like that to be a nice round number like 30, 40, and 50. Excel is suggesting a class interval of 10 units. Therefore, in order to get my first class to end at 40, I should start at 31. When I do this, You see that it puts in row labels of 31 to 40, 41 to 50. And Ogive also always begins on the x-axis with a y value of 0. If I click the drop down, I can see that there are two classes that are not included in my table, less than 31 and greater than 101. I'm going to force Excel to show those classes under Field Settings, Layout and Print, Show Items with No Data. Notice that the count still doesn't show a 0. Excel does not like to include values of 0 in a pivot table, but will force the issue under Pivot Table and Options for empty cells show 0. And I don't need that last class because my cumulative table needs to end with my final value of 30. Now I can change my count of used to a cumulative number under Field Settings, Show Values As. Instead of No Calculation, I'll pick Running Total. Values on the x-axis are the upper value of each bin. So I need to change my row labels from the width of the class to show only the upper value. To change these labels, I merely inserted the cursor into the cell and typed 30 and then 40. We also need to have a cumulative frequency column. I'll drag the used over to values once again, and that will add a second column. And I'll change it to be percent cumulative. I'll change this to show values as percent running total. Now we're ready to insert our graph. Insert, pivot chart, and I want to choose a line graph. I'll choose this one. Notice that it has two lines in, not to worry, we'll fix that. Clicking OK, I can now go in and on the Format menu under Series Count of Used 2, I want to change that to have it be on the secondary axis. Notice that my axis ends at 120% and 35. We would like it to end at 100%, and we'll end this at 30 on the primary vertical axis. Right-clicking on the secondary vertical axis, we'll choose Format Axis, and we'll change the maximum to 1. And then under the vertical axis, we'll change this value to 30. And now our lines are lying on top of one another. I'll click on the plus sign and get rid of the legend. And we are essentially done with this graph. Good chart formatting says that we should have axis titles and chart titles. Easy to add with the click of a button. And then you can change those titles by clicking inside the text box and typing the title you'd like. And here we have our completed ogive, or cumulative frequency polygon, with an S-shaped curve beginning at the x-axis and moving up and to the right until it reaches 100% cumulative frequency. In this video, we have shown how to build an ogive, or cumulative frequency polygon, using the pivot table and pivot charts features in Excel.